So in my recent video covering the SR-22 wake vortex accident at Knoxville, Tennessee, I used USAir 427, the 737 crash at Pittsburgh, as an example of a wake vortex crash, mostly to point out the mechanics of the incident, of an incident like that, but also to show that it can happen to just about any sized airplane. And what I did was create a mini storm of controversy, because a lot of folks have, shall I say it, a less than perfect understanding of the part that rudder hardover played in that accident. So stick with me on Flywire, and I got my flame suit on, sort of. Let's look deeper into that event. Hey, I'm Scott Perdue, and this is Flywire. This Flywire video is to address the semi-controversy I started with the wake vortex video. So here goes. You might not get what you expect out of this one. I had a lot of comments and a bunch of emails over what I said about the 737 USAir 427 crash. It seems that most people believe that the airliner crashed because of a hardover rudder incident and took me to task over that. I tried to answer each one, but after a while I just said, okay, fine, I'm just going to do a video because it's going to make it easier to go in a bit more detail about it. The funny thing for me is that I was just using that accident as an example of what a wake vortex encounter could do. And it looks like my points got caught up in the wake of my example, so to speak. Anyway, the whole topic hinges on the Rudder PCU design of the 737. A PCU is a power control unit, and in this particular application, it's a two-way hydraulic ram. Pressurized hydraulic fluid is poured into one side to push the rudder one way, and then the other side to push it the other way. It's got a little slide valve in there. The 737 valve was designed to have kind of a fail-safe redundancy within the valve, so that if it jammed or lost pressure from one direction, the fail-safe would move the rudder towards neutral instead of full deflection. Complicated valve. During investigation of the USAir 427 accident, the hardover rudder, which did occur in that accident, and the PCU came under scrutiny. It turns out that in the secondary slide could momentarily jam when hot hydraulic fluid was applied to a cold valve. And when that happened, the primary slide could over travel and actually deflect the rudder in the opposite direction commanded by the pilot. But in all the tests, it was just for a few seconds, not for a long period. All this would happen and not leave a mark on the failure at all when the pressure was removed from the system. It just wouldn't be a mark. There was a defect, a flaw in the design. The hardover rudder had happened in the 737 more than once. 3 years before the crash of USAir 427, a United 737 Flight 585 crashed at Colorado Springs, and rudder hardover was a factor there. It was a short flight between Denver and Colorado Springs. The VFR day, about 9:44 in the morning, when 585 turned final for runway 35. The visibility was 100 miles, temperature was 49 degrees, and the winds were 330 at 23 knots, gusting to 33. Not too terrible for runway 35 in Colorado Springs. It's windy there. As 585 approached the Springs, they listened to the ATIS, and the report was wind at 310, 13 gust 35. Low-level wind shear advisories in effect, and a wind warning calling for northwest winds gust 40 knots and above. Windy. At 9:37 and 59 seconds, the tower controller cleared the flight to land with winds 320, 16 gust 29. About 30 seconds later, the FO asked for reports of gain and loss of airspeed. The controller responded that a 737 a little earlier had reported a loss of 15 knots at 500 feet, plus 15 at 400, and plus 20 at 100 feet. The first officer says, "Ooh, sounds adventurous." The winds are going to be all over the map. The only thing consistent here was it was blowing hard and gusty. Witnesses reported that the airplane rolled out on final and then rolled right until it was inverted with the nose nearly straight down, descending to the ground. Another witness 6 miles away reported several rotor clouds in the area about 10 to 15 minutes prior to the crash. The flight data recorder showed the airplane turning onto final at 155 knots with 2 to 10 knot excursions. Passing 1,000 feet, the AGL, the FO made the 1,000-foot call out, and then 4 seconds later, the heading going to about 5 degrees. That equates, per second, that equates to about 45 degrees of bank. The last 8 seconds of flight, the engines were pushed up and the captain called for flash 15. That's go around. The airspeed increased rapidly and then increased to 200 knots. The load was 4 Gs, and boom, the impact point was about 212 knots at about 16 degree angle of attack. The airplane had been inverted and was pulling through the vertical to upright at about 80 degrees nose low at the point of impact. It was at the beginning stages of recovery. Colorado Springs had a working low-level wind shear alerting system, and the recorded winds were a little different than the observed winds in the tower for an undetermined reason. They didn't say why. Data from the Chatfield Profiler 53 miles northwest showed the northwest winds at 39 knots at 6,000 feet, 142 knots at 15,000 feet. Reported moderate to severe turbulence with mountain waves in the area. After the crash, the CVR, the cockpit voice recorder, and the flight data recorder were recovered. Both were damaged, but both were usable. Unfortunately, the FDR only recorded heading altitude, airspeed, G-load, and microphone keying. The CVR was also damaged, and poor quality audio, but it was usable. During analysis, the NTSB ran tests to match the recorded data with different scenarios. One matched perfectly where the Rudder PCU secondary slide had failed at 100% off of neutral, and the rudder reversed in response to the pilot's attempt to make a left rudder input to counter the right roll and yaw. The right roll and yaw rate was a result of a wind gust computed to be 17 knots for 3 seconds. The investigation also matched recorded data on right yaw and roll rates, descent rates, etc., with the possibility of a standing rotor. Boeing disagreed with the report, citing that the standing rotor theory was the correct one. However, in order for the standing rotor theory to prevail, it would had to have increased in strength when it hit the ground and be more intense by several orders of magnitude than any documented standing rotor had ever exhibited when it hit the ground. Additionally, no changes in airspeed consistent with the required rotor strength were recorded by the flight data recorder. So the NTSB found the probable cause was the PCU failure and the hardover rotor. Note that this conclusion came after the investigation of USAir 427, and in large part it was aided by the 427 investigation. Before we go back to USAir 427, I want to point out one more 7.3 with rudder hardover incident. In June of 1996, East Winds 517 experienced 2 temporary rudder hardover events, causing a right yaw and roll. The airplane was at 4,000 feet and 250 knots when it happened. No conflicting traffic was apparent. The airplane was controllable and landed without incident. Remember, USAir 427 encountered wake turbulence from a preceding Delta 72 at 6,000 feet. In this case, the yaw and the roll was to the left. Right aileron was applied as well as back stick. For some reason, the left rudder was applied fully, followed by the right rudder, and then partially back left. The airplane continually rolled left as the crew held full right aileron and full aft elevator, impacting the ground. This profile matched the recorded movements of 427. The rudder did indeed experience a jam or lockup. It was triggered by the flight crew's rapid application of large left and right rudder inputs. And in the end, the airplane was uncontrollable with the imposed application of the flight controls. And that brings me to perspective. For some reason, people are drawn to focus and look for a smoking gun. I know that I am at times as well. I'm human. We're all human, hopefully, watching this. It's somehow better to attribute a terrible accident like this to a mechanical failure than the crew. At some level, in our psyches, we need the absolution to cover our own vulnerabilities as pilots and humans. I think that tendency clouds our ability to perceive the big picture and determine the underlying causes and address them in a meaningful way. There's not enough recorded data in East Winds 517 flight to determine what actually triggered the rudder hardover transients. Okay? So it just happened. But one important takeaway from that incident was that at some speed, the airplane is controllable even with hardover rudder. In both the previous accidents, the rudder hardover was triggered by a pilot input, 585 and 427. I discount the hot hydraulic fluid on a cold valve theory as a prerequisite for the jam. Notably, 585 was cruising at 11,000 feet for less than 20 minutes in 45 to 50 degree temperatures, considerably different than the extreme cold of 35,000 feet. The common denominator here is the pilot input to the rudder to counter an upset triggered by and that triggered the jammed rudder. For 585, it was moderate to severe turbulence and gusty winds. For 427, it was a wake vortex encounter. For 585, the incident occurred at 1,000 feet above the ground at 155 knots, fully configured for landing. For 427, the incident occurred at 6,000 feet at 100 knots with flaps 1. For these three accidents incidents came the concept of crossover speed, and this is important, frankly. It's foot stomper. Crossover speed is the speed at which the aileron can overcome the roll due to yaw of a hard-over rudder. The speed is in the range of 170 to 210 knots, depending on weight and configuration, and entry speed. The block speeds for certain flap settings for the 7.3 were raised to knots to accommodate this crossover issue. For the crew and passengers aboard 585 at 155 knots and 1,000 feet, there was not enough altitude or time to accelerate to crossover speed and regain control of the airplane, if they knew about it. They didn't. For 427, it was in or near the speed range where the control could be reestablished if flown correctly. On a side note, as a result of this accident, a survivor of one of the 427 passengers sued USAir more than a decade later. Two of the people deposed for that lawsuit were USAir flight managers, and one of them was the man at the time of the crash. They both said that if they had known about the issue of the 7.3, they would have changed the procedures prior to the crash. And with that new procedure, quote, I would have expected the 427 crew to successfully be able to fly out of that situation, end quote. Pretty important. This is about where you're going to get mad at me for blaming the crew as being at fault. Where did we get the idea that pilots are infallible? Pilots are human, at least most of us are. Bad crack perhaps, but any one of us is one bad decision, one overlooked detail, one mistake away from disaster. Complacency is our own worst enemy. And I'm going to flip it back at you with the question as to expectations. If we don't act as adults and rationally look at the entire picture, we will miss important details to come up with solutions. We will just chase our tails around and around in circles. I propose a scientific way of looking at these situations. There is no such thing as a magic bullet, just as there's no such thing as being omniscient. For those of you in Rio Linda, of course, that means no one knows everything. We know stuff, we develop procedures and knowledge based on trial and error. So much of what we know in aviation, it comes from things that are written in blood of those who have gone before us. The best thing is to learn from the mistakes of others. These crew dogs weren't aware of hard-over rudder in 585 and 427. They knew nothing of crossover speeds. How can I expect them to perform and recover the airplane correctly when they have entered it into the realm of unknown? We know now because of them. They were pioneers that paid the ultimate price for the knowledge we now have, and we respect them by using that. This error doesn't make them bad people or bad pilots. They were in a situation they were not aware of and didn't know how to recover from. I think it is imperative that we respect their sacrifices and learn from their mistakes. To cover those mistakes hides an important part of the equation to make things safer for the rest of us. The big result of this PCU jam is that the accidents is that the system was redesigned and flap speeds were adjusted to ensure you're going to be above crossover speed for your configuration. And this applies to way more airplanes than just the 7.3. This is progress. It comes in fits and starts, but it is progress. Restricting the discussion and argument to the mechanical feature of the accident, the smoking gun, is only a partial solution. I would say that this is true in any accident, but very important in 585 and 427. Human factors can be found in everything we touch. Both were caused by pilot inputs following an externally encountered upset. And as an example here, the entire story of the rudder hardovers, the full deflection and transient inputs in both directions, was not revealed until American 587, the Airbus A300, then encountered the wake turbulence from the preceding 74 JFK. I mentioned this in the video. In 427-585, they found the smoking gun, case closed, no need to look at what the crew did and why and the potential impacts if somebody did it in the future. The pilot rudder reversals were obviously an untrained human reaction. That's what the FO did in 587. And, you know, it's just time to move on. A lot of folks paid the price for that mistake. An example like this are Legion. We are not standing on the shoulders of giants here, and we should be. A friend of mine also sent me an email from this issue in our conversation. He posed the question of what percentage of current airline pilots would be able to handle this situation successfully, now that we know all this. What about GA? Well, leave me a comment below with what you think. Okay, that's my take, and we got to try and get better, and we got to call it where they are. Okay. Plus, you get to see where I'm coming from on USAir 427, as well as accident reviews in general. Thanks for hanging with me. By the way, if you didn't watch the video on wake vortex upset, spoiler alert, unload the airplane, push your way through the core. Any G increase is the overspeed, the crossover speed. Okay. Unload, get out of it. If you like the video, hit like and subscribe, the bell for notifications, and it looks like a bit like this here. And I'd like to thank my Patreon supporters here as well. I appreciate you guys. Without your help, I couldn't do this. And I'll leave a link down below if you'd like to support the channel on Flywire. I'll see you next time on Flywire.